Hi everyone, welcome to Quick Soil Mechanics Lessons with Brian. Today, liquefaction simply explained in 12 acts. In reality, I don't know how many acts there are going to be. Let's just go with it. Act 1, stresses and the Mohr-Coulomb envelope. Well, let's talk about an element of soil in the free field. So we've got our ground surface, in this case it's horizontal. We have our soil element somewhere beneath the ground. Notice I haven't drawn an embankment or sloping ground or anything else. It's just a happy little soil element somewhere beneath the ground surface. And there's a vertical force on that soil element as well as a horizontal. And we call that a vertical stress in soil mechanics and horizontal stress. And remember, a stress is a force per unit area. So to be an area, the element has to be 1 unit thick in and out of the page. Okay, before a whole bunch of people come at me and tell me my element is not statically correct, that is right. I haven't drawn all the forces on it that needs to be. I just took a little shortcut to save some scribbling. So there would be balancing forces in this in the ground, otherwise it would be moving. And there could be shear stresses on it as well, but in our case, there aren't any shear stresses. Now let's go back to our little soil element in the free field. So that vertical stress, or sigma V, is equal to the unit weight of the soil times the depth of burial. And if we're talking about effective stresses, we'd subtract out the pore pressure, and that would make it sigma V prime. So the horizontal stress, sigma H, is equal to sigma V times an earth pressure coefficient, or sigma V prime if we're using effective stresses, and then we'd have sigma H prime. For a normally consolidated soil, we use the at-rest earth pressure coefficient K naught, and K naught is equal to 1 minus the sine of phi, friction angle, or phi prime as the case may be. So getting back to our soil element, and we're talking in this case in total stresses because we're disregarding pore pressure or it's above the phreatic surface. Now we've got an axis where we can represent these points graphically. So the horizontal axis, we have normal stress, vertical we have shear stress, and we've got our first point, which is sigma V, and notice there's no shear stresses, so it's right on that x-axis. We also have sigma H, which is less than sigma V in this case because we've multiplied it by the earth pressure coefficient, which is less than 1. So it's smaller than sigma V. And we have the convention of connecting those two with the upper half of a circle. And there'd be a corresponding lower half of the circle if we were also showing negative shear stresses. But in this case, we're not. We're just working in the upper half of the circle. So we have a failure envelope, and that is represented by the friction angle. And notice the circle is not touching the failure line because it's not at failure. It's just a happy little soil element beneath the ground. And that brings us to the end of today's lesson. Thanks for watching.